Hello, this is Miss Dagenford, and we're going to be looking at lipids. And this is the second of our organic chemistry videos. Now, just as before, the chemistry of lipids will influence its behavior. And just as before, a quick review of polarity. You are going to be looking for molecules that have an oxygen and a hydrogen, and those are called hydroxyl groups, or a nitrogen and a hydrogen, two hydrogens, pardon me, and that's an amine, and that's going to indicate that that is a polar bond. If you don't see those, then that molecule is nonpolar. And again, quick review, a nonpolar molecule has an even spread of electrons, which makes the molecule overall neutral. So a good example of this is going to be a hydrocarbon, where if we were to draw where our electrons are, we have an even spread of electrons, whereas in our hydroxyl group we'd have our electrons over oxygen predominantly and nitrogen predominantly, which gives oxygen a partial negative and nitrogen a partial negative. Hydrogens are partial positive. But so these are polar, but because of this nice spread of electrons, there's no one area that has more electrons than any other area. So this is nonpolar. And also that also means it's going to be electrically neutral, which means it has nothing for water to be attracted to. So one of the first big characteristics of lipids is that it is nonpolar. All lipids are nonpolar. The other term for nonpolar is hydrophobic. Now this is a convenient term. It means water-fearing, but don't get this confused. It doesn't repel water. There is really just nothing for water to be attracted to. So it just, water excludes it. It's like being at a party and you've got all of these people having a grand old time dancing to their music, and then over in the corner you've got the party poopers, which are just, you know, they're not they're not dancing. It's not that these partiers are repelling them, they're just not getting attracted to them, and that's kind of the idea of lipids. Now, we don't see polymers like we did with carbohydrates. We don't have monosaccharides, disaccharides, polysaccharides. We don't see that. So the big characteristic is going to be our nonpolar. So the first grouping is going to be fatty acids and fats. Now, to make a fat, you're going to take a glycerol backbone, and then you're going to add fatty acid tails. And I'll show you a picture of it in just a second. So if you have one fatty acid tail, we'll have a monoglyceride. If we have two fatty acid tails, we would call that a diglyceride. And then if you have three fatty acid tails, a triglyceride. This is something that, for instance, we can measure in our blood to kind of get an overall idea of how healthy we are. Now, these are also formed through dehydration, synthesis, where we're going to remove a water in order to make a larger molecule. Now first, the other thing to go over is the difference between saturated and unsaturated. In the saturated fatty acid or fat, all available bonds in that fatty acid are connected to hydrogens. So this one down here, this is a saturated fatty acid. And every one of these bonds is a single bond. It's connected to the carbon, to the hydrogen, and so we call that saturated because every carbon has as many hydrogens as possible. The unsaturated, we do see some double bonds, and I'll show you that in just a second. So first of all, let's make sure we are clear about the dehydration synthesis. Here is our water being removed, and because of that, this oxygen can bond to that carbon. And that was probably not a very good arrow to choose. So let me do that again. This oxygen can bond to that carbon. So if we go to the picture down below, here it is. Oxygen bonded directly to the carbon. We call that an ester linkage. So if we do this 3 times, here would be another fatty acid, here would be another fatty acid. We would get then a large triglyceride. Sometimes you see books calling them neutral fats. Now over to the right, here's the difference. So here would be a saturated fat, very nice and linear. And saturated fats, notice the picture we have butter. These are, many of them are animal fats, where they are solid at room temperature. And the reason they're solid is because of that linear form, they stack up nicely next to each other, and that means they can solidify. They pack together well. In an unsaturated fat, notice we have this little double bond here, and if it was a polyunsaturated fat, you might have another double bond. And this double bond creates a little kink in the fatty acid tail. You'll notice it kind of bends right here. Now this kinking of the fatty acid tail means that they don't pack well. Notice this is an oil. It's liquid at room temperature, and that kind of defines an oil. These are unsaturated fat molecules. Now, this means they don't pack well. They're slightly better for us because they don't make the same kind of clots that saturated fats do. And the main job of these is for storage of energy. They do a really good job packing the calories. And I know we tend to have negative ideas towards them, but they're really good at it. And for storage, that's great, storage of energy. Now, the next class of our lipids would be steroids. Now, imagine taking one of those big, long fatty acid tails and then doubling it back to form rings. And remember, I said in the previous video, anytime you see these angles with nothing else there, it's a carbon. And unless there's an oxygen or a nitrogen, you can also assume that there's hydrogens around here. So this would be a carbon with 2 hydrogen. This would be a carbon with 2 hydrogen. This would be a carbon with 1. This would be a carbon with 2. And one of our big points is, notice, very little oxygen. Very little oxygen. And that goes back to its nonpolar nature. There are no partial charges in this fatty acid chain. So water is just going to be coming up with its lovely partial negative and partial positive. Water is just going to come up, and then there's nothing for it to be attracted to. And that's going to be the reason why oil and water separates. There's just nothing for it to bond to, water. And so eventually water is going to be so attracted to the other water molecules that it just excludes the oil. It doesn't repel it, it just excludes the oil. So with steroids, the big key recognition is these 3 or 4 carbon rings. This is so classic, and we see these in hormones, cholesterol. The same basic 4-ring structure is going to be the same. What differs is what gets connected to these little carbons. That's what identifies it as a specific steroid. It is also nonpolar, and again, notice we got only one little hydroxyl group. that would be polar. We'd have a partial negative and a partial positive down here, but overwhelmingly the rest of this molecule is non-polar, which means that this little teeny tiny polar molecule down here doesn't really influence the overall interactions. Now, phospholipids are an interesting case. They are what we would call amphipathic. Think amphibious, meaning it can go both in the water and land. Amphibious tank, or an amphibian, a frog. Now, these are going to be similar to fats, but we're going to substitute a polar group for the third fatty acid. And because these bonds can swivel, this polar group is going to attract water, and it swivels around, and then the fatty acids are excluded from water. We're going to see this in our membranes. So down here is a very classic example. Here we have our glycerol backbone, and where we might see a third fatty acid chain, it's replaced by this polar group. We have a choline molecule, which here it has a positive charge and that nitrogen, and then here we have a phosphate with a negative charge. These are going to carry some partial charges as well, and so this is very, very much charged. It's got some partial charges, full charges, and this is very much neutral, and that's going to play a very interesting role because water is going to love this part because of all the charges, and it's not going to be attracted to the fatty acids. This creates the micelles and the bilayers, which we should remember from previous classes. So that's a quick review for lipids, and you'll have done a couple of questions right now for these. So just a quick question for you. I'm just going to draw one out. And I just want you to I want you to answer a couple of questions about these. And I'm just going to label. Thank you. And we will talk about these tomorrow.